giving free certifications and vouchers to every of our attendees. I don't think for this time it will be possible because we didn't have, um, they couldn't let us access the certifications. But I think for the next session it will be possible. We have already planned the next session. You will have it, in fact, on your emails. When you plan the next session, all of you will have it. So I think Ali is ready. Ali, are you ready?
Yeah, I'm ready. Please assure me if my voice is clear and my screen is visible to you.
Yeah, I think your voice is clear. If anyone has an issue, he can actually write it at the level of the chat section. And also during the presentation, please, all your questions, put it at the chat section, and Ali will have the time. Ali and I will have the time to actually review it and answer your question at the end of the presentation.
Yep.
So Ali, please, can you give us a quick presentation before we start of who you are and what you're doing?
Okay, thank you so much for inviting me today here. And so the title for the today's presentation is tips and tricks to ace certified SolidWorks professional advanced exam of the sheet metal. And my name is Ali Haider. I am the founder of the Digitize Studio, and I am a SolidWorks champion, and I have the title of certified SolidWorks expert as well. I am a top rated plus seller, a mechanical design engineer on Upwork, and I am an expert design engineer at Machisol. So with these titles, I am having 17 plus certifications from the Dissolve system, and that's pretty much it for me. And I have experience of around 3 plus years. So, for the agenda of today's session, we are going to discuss some of the details of the exam, and this is very to the point, presentation for our exam. And then we are going to learn the tools that are basically used for the certificate and are important to be practiced before going into the exam. And then we will be I will be showing you how to use those tools, some practical tips. And then we are going to see the tips and critical points that you must know in order to finish the exam correctly, because we face the issue at the end when we are doing the good thing but actually our answers are wrong. And then we have the sort of like practice exam with like 5 to 6 questions. We will go through them, and I have other list of questions in order to help you understand what will be the structure of overall exam. And that's pretty much it for the agenda point. So starting with the exam details that can be found on the official website, and it's a total of 15 questions and 145 points, of which 100 will be the passing score, and you will be having 90 minutes to finish the exam. So towards the important tools that you must know before you can say uh, like starting your exam. So first of all, you don't need to just like know that where these tools are, but you actually need to practice them on SolidWorks. So starting with the edge and the meter flange, let me open my SolidWorks screen as well so that we can see them side by side. Just show me if you can see the SolidWorks screen as well. Fortune, please confirm that.
Yeah, I can see your screen. It's perfectly fine.
Okay, so I will be switching back and forth between the tools and the SolidWorks screen. So please be attentive on the screen. So first of all, we have edge and the meter flange. So let's start with for example, we have a base at the like a plain sheet like this, and I am just putting some random dimensions. And then I'm just going towards the sheet metal. Here you can see on the tree we have nothing, but when we go into the sheet metal and start the base flange, and here we will put the thickness of the sheet as 2 mm. And I will be only talking about the tools or the parameters that are important for the exam point of view. Other than, we have a lot of stuff happening in there, but I will be focusing on the things that are basically used in the exam. So I'm going to change the thickness and reverse the direction in the upward and click on OK. So this is our base flange. Now you can see we have this folder here which is sheet metal. So actually we are into the sheet metal thing right now, and here you will find the edge flange and the middle flange. So starting with the edge flange, just click on the edge flange, and you can just click on any of the edge that you want to, like, make a flange there, and then we can just change the parameters from here. Like, we have the default radius of 0.736, but you can overcome that and change it to 0.5 mm or whatever value you want. And we can even change the angle to 50. Like, you can update these, and here we have the extrusion, which can be increase from there. And here we have, like, from the icon you can pretty much clear that inner virtual sharp and the outer. This is actually the length, from where the length will be starting. So it's from the edge, and it's from this extrusion point. This is the from here. At this point, it's 50 extruded, but for the other one it's from the edge, from the corner. And here is the flange positioning. When I, like, zoom in there, you can see we have the base, and the flange is being extruded from the outside. And if I change it, make it inside, you can see that now the flange has been shifted towards the inside, removing the material from the base itself. And similarly, you can play with these in order to achieve the one that you desire. So this is basically the edge flange. And if you want to create on all the side, you can just simply click on those edges and press on OK. So let me just remove few of them to test our other flange as well. So this is edge flange, which is basically a linear edge flange, you can say that. And in order to, like, have a meter flange, which means if you don't have a straight flange but you want something to be like of different shape. For example, if you want, let me create a sketch in there. Actually, a meter flange works with the sketch, so let's create a sketch first. And for example, if I have something like this, just a random shape basically, and let's put some curve as well. This is a random thing. I'm going back to sheet metal tab and click on the meter flange. So you can see we have the flange on the edge, and we have all those same parameters, but we just have this gap in there, which is the gap from the edge. Edge means from this corner. In order to understand this thing, let's cross this out, close the sketch, and change sorry, excuse me, let me change the angle to 90 so that we can see what that specific thing means. So here you can see, if I change this distance from here, if I change the distance, the parameter will be shifted from here. So this is the basically a gap. We will talk about this thing later on as well when we covering the corners as well. So these are the parameters, but the main concern is, if you want to create some edge flange like this, you will be going to use the meter flange. And similarly, moving towards our next approach, which will be the hem. So in here you will see the hem, and these are pretty much the same questions that are being asked in our exam. So in order to create the hem, what you are going to do is, we can just click on the hem. You had to click on one of the edge. Let me remove this thing. Like, reduce the length. Okay, so I'm clicking on the edge, And we have this length, which is extrusion of this thing, this flap here. You can see this. So we can just, this is simple thing, but in order to learn for the exam point of view, you may ask to create a the hem on the center only, or at any distance there. So for that you need to create edit hem width, which is like editing our profile for the hem. So when we click on the edit, here we see the line. We can just drag the points, we can give it the dimension, we can give it the distance from the edge like this, and click on back. You can see we have now the hem on the middle portion only. So this is how we create the hem. Then moving towards the jog. So for the jog point of view, let's create like, it works with the sketch. From the icon you can see we have a line, and then from there it is bending. Sorry, it's jog. So for the jog point of view, we need to just create the sketch first. Let's create a sketch in here till this. And you need to make sure that there is an enough gap in here that can encounter the radiuses as well. So I am moving it away from there, and then just go back and click on the jog tool. So it is asking about the fixed face. For example, if you want to change this edge, and from this face you want to change it in the upward direction, like if I make it horizontal, you want to bring it horizontal and then move up and then again make it horizontal, then we are going to make give it a fixed face, which is basically, I am putting this one of the face here. And let me repeat this. I was going down, I was clicking on this face, so it is not working. Why? Because our sketch is on the upper face. So that's why you need to select on the face that has the sketch. So I have click on that thing, and here we have our default radius, same parameters. We have the jog offset, which means if I change the value, you can see from the face it is offsetting 2 mm in the upward direction. I can change the value, and this is how it changed. And from these, you can say the icons, you can see how the distance is changing. It's actually like from this face till the top face it's 5 mm. So if I change that thing from the bottom of this yellow face and this top face, it's 5 mm. So these icons can help you visualize what you are doing on the screen. So that's how you create jog. And moving towards the next is sketch bend, which is actually like creating a sketch bend. For example, if I want to create bend this face as well to and make it horizontal, so what I will do, I will create a sketch in there, a horizontal sketch like this. You can see we have the sketch. I will move this little bit down, and then I'm going into the sheet metal tab, clicking on the sketched band, and again we have the sketch on this face, so I'm going to click on the face. So you can see we have the bend in there. So we can change the direction, whatever we want, and I want this to be like this. So this is how we can put the line and create the sketch from there. If I want to change something, like create some more bend from here, I will add another sketch like this. I will just go back to sheet metal, click on the sketched bend, and then from the face I will click on it. You can see we have the sketch bend. So this is how we can create sketched bend. Moving towards the next is the forming tool. I want to create a forming tool here. So for that, these are basically the design library features. So what we are going to do, we are going into the design library. From the design library folder, you will see some forming tools. I will double click on them, and we have different forming tools in there. I will click on levers. I will just grab it and drag on the face, and from there we can change the position, like flip that. We can change the angle. We can position that by clicking on the position tab here, and then we can assign the dimension to it. From the top I can put the dimension, and from maybe left hand I can put the length. It's basically the edge, so I will increase the distance. And once I am okay with this, I will just click on OK. So here you can see we have the forming tool. So then we can just play with that by maybe we want to create the feature as a pattern of this feature. We can create two of them, reverse the direction, increase the distance, and click OK. So we have that thing. Okay, so moving towards our next, which is unfold and fold. So here you can see we have this fold at this position, but you want to make some changes in there. So for that you need to just click on the sheet metal tab. Go here, we have two the parameters here, which is unfold and the fold. I will click on unfold first because we have the folded region there. I'm clicking on unfold. Click the fixed face. So if I want to make this face, vertical face, as horizontal, which is parallel to this one, so I'm selecting the fixed face, this one, and the bend to unfold. So this is the bend that I want to unfold. So I will click on that bend and click on OK. So here you can see we have unfold the bend. So I will make any change if we want on there. Just cut that, link to thickness, click on OK. So this is how it's changed, and then now I can make again change that by clicking on the fold. Face has been already selected. We can just replace that face as well, but I am going with the same. And go back, click on the band, click OK. So it will again back. So although we can create this in here as well, but in some cases we have to fold the unfold or fold our bands before making those cutouts or any divisioning in the sections. So moving towards the next is the flatten. So this is very to the point, easy tool. You can see here flatten. So the point, you can see our model has been flattened out. And for the sake of, like, if you want to see the bent lines here as well, you need to go there in the eye section, and from here at the top bottom you can click on that. So when you will click on here, you can see we have those lines in there. Let me change that if we can visualize that. So here you can see we have the bend lines as well. So if we want to create the drawing from that, although this is not the part of the exam, the creation of the drawing, but if you want, you can this can help you with that. And other than that, maybe you will face something like if I go here, click on this, edit it, and click on merge faces. Okay, you may face your part is looking like this. So in this case, you can just go there into the flat pattern, edit it, and click on unmerge faces and click OK. So this is how it will look like. So this is basically the method to flatten our component. Moving to the convert to sheet metal
Ali,
part.
before please, Ali,
Yeah,
before you go to the next step, can you
yeah.
just show the unfold feature again?
Fold
That was the
and
question from the
unfold.
chat. The unfold, the
Unfold.
unfolding, when
Okay.
you fold, how to unfold. That was the question from the chat.
Okay. So here we have like unfold command. We can click on there. We have to tell them a fixed face that we don't want to move, or we can say that with which we want to like align our component. For example, I want to align this top make the this vertical flange to be horizontal and in parallel to this one. So I'm going to click on this face and click on the bend, and it will, after clicking on OK, it will automatically make it unfold. And in order to repeat the process, we can just create a fold, same face, click on the bend, and we can fold it back. So this is how we use unfold and the fold commands. So these are very like easy the folding and folding technique. This is not much useful in term of exam as well. There are some points then that at that you need to try to unfold the flanges, but this is not the always the case. So you, if you want to like make the changes, you want to create some cutouts, you can create that from unfold area as well. Like if I create the cutout like this, and if I make it, flatten it, it will work actually, no worries at all. So we can do that, but sometimes we need to maybe unfold that to in order to make such cutouts, or maybe we need to remove the bends as well. So in that case you must know how to unfold and fold. Yeah, you have to make sure that you are doing all those stuff above this thing, this flat pattern folder, you are doing above this thing. But if you are going anything below that, then you are going to like face the issue regarding that will not be going to bend the things that are below this folder. So make sure that you are working uh, everywhere inside this. And I hope this will answer the question. Moving towards convert to sheet metal, this is a complete section. These are basically the tools that are being used with the single, just like we are doing here, starting from the base and converting the whole part into such a complex shape. In SolidWorks exams, you are doing the same thing. You will have one question number one with the base, and then you are going to add the features, change the parameters, remove the features, and those will be your next questions. So in order to make them correct, the question number two, three, four, you have to actually make sure that your question number one is correct. So let's move towards convert to sheet metal part. Let me open another part from my folder. Let's go back to recents. And yeah, this is one of the question from the past exams. And actually this is a solid body, and the question will be, you need to create like convert this part into a sheet metal component. So for that, what you have to do is you need to go into the sheet metal the tab, and there you will see the command, the convert to sheet metal. What you are going to do is click on the convert to sheet metal command. Here you need to specify the fixed face. So from the question you will understand which one is the fixed face and what are the bends, because you will see in the image, the reference image, where are the bends and where are there is no bends. So for example, if this top face is the fixed face, I will click on that face from here, select the fixed face entity, so which is face one, and then we need to collect all bends. You can click on that. If it works for you, that's great. If not, then you need to manually select all those bends. For example, if I click on this edge, then this edge, moving towards this edge, on the back this edge, so these are selected. Now moving downwards this edge, so you can see our body is being converted. And then I can click on this edge and this edge. So here you can see our all the covers has been replaced. We can click on this one as well, and this is like the bends have been collected. From here you can see we can reverse the thickness as well, inside outside, and we can override the default parameters of the thickness as well. So I'm going back and click on OK. So here you can see we have the part converted into a sheet metal. So the question will be, you want to enclose the solid component into the enclosure, so that's why we have converted into a sheet metal component. And if I go down, delete this because of the feature already created. Okay, so here we can see if I click on that, we have the flat pattern. So this is your one question actually, and you will have to find, the mass or something like that. I have those questions at the end of the sessions. And from there you will be just playing with the tools like the added flange, changing the radius, sketch band, meter flange. You need to create the hem. So all those are going to be added on this, and those will be your next questions based on this. So if your this very first question is correct, then rest will have the chance to be correct. But if you have this as a wrong question, and all of your rest of the questions are correct but your base part is wrong, so that's why your next questions, all the questions will be wrong. So make sure that your first one is correct. So each new question, each new part that starts from the very first question, you have to focus on that question. You need to spend the time on that question, and then later on all the questions will be having greater chances to be correct. Moving back to convert to sheet metal, done. We have sheet metal cut list. So where we can locate that, we can see here we have a cut list folder. So for now we have this one convert solid body because this is a single sheet metal cut. This is from a flat sheet which we can cut. And so you can find the cut list from here. If we have multiple components, then we can you see the multiple components in there. For example, maybe that will get something wrong, but let's create something on the top plane. Other than this body, I'm creating some base here. I am just going to sheet metal, making it a base flange, and reverse that full direction. Okay, and I am creating some edges there. Okay, and again I'm creating some edges here as well. Okay, from here. So this is another component. Now I'm going to flatten it. You see just one component here, but actually in the flatten pattern folder we have 10 and flat pattern 11. So if you press this one and unsuppress the second one, you will see the second component. So these are two basically the cut list, sheet metal cut lists. So I will just press both of them, go into the cut list. We have all both of those as a cut list. So this is this from there you can see the cut list and manage them. You can create automatic the bill of materials of these cut list in the drawings. This is extra tips. This is not a part of the exam regarding creating the BOMs, but you need to play with the cut list from here. You need to see the properties from here. Okay, moving towards the bend tables. This is actually when we have this sheet metal folder, you can just edit that. We have this gauge table, which is click on that and we can select the bend tables from here. We can browse our own table as well. That will be given a question that they will give you the bend table. You need to browse that table, select that file, and that will be loaded in here. And then you have to select the gauge which is mentioned in the question. So you will select that gauge and click OK. So that will be your the sheet metal component updated according to that gauge, that thickness. So this is how you will modify that. You will modify the gauge table from this. So that's like tools that you need to practice, and I have helped you to practice in front of you in the session today. So this is how you will.
Ali, before going to the next, I want us. I
Yeah,
just want to ask a simple question. I think maybe it's not
yeah,
part of the exam, but it can help everyone. How do we actually create and save our own forming tool? Like, if you are working on an enterprise setup and you are actually
yeah,
assigned to build, let's say, sheet metal part, and you want to create your custom forming tool, what are the steps you're going
yeah.
to go about to actually create that forming tool?
Actually, fortunate, that is not the part of the exam, but we can create that, and that will just take some time. So that will make our session lengthy, and I have other commitments than that. So we can just like talk about that later on, and for now we can just focus on the session title, I guess.
Okay, okay, no problem, no problem. You can
Yeah,
go on.
we can cover that thing later on, but yes, we can create custom, like if I open this part as well. So this is a tool, forming tool basically. So we need to just modify this and just save it into the library, the design library. So we can maybe change the lengths of these, we can adjust this, like if we want to extrude this, we can increase this length. Mid plane is according to the bums, which is like design library thing, but we can put the manual dimensions, we can increase the dimensions and just save that into the design library. But that will take us time, but and which is not like good for us to be aligned with the session.
Okay, okay, perfect.
Yeah. Okay, so moving towards our next is tips and tricks. So these are basically the things that like people will do the stuff that we have already done in the previous slide. But actually, when it comes to giving the answer, the right answer is important. So where do you find those answers? For example, they are going to ask, like, you have created the model, you have flattened it out, I want to see the bounding box area. So where I will get that bounding box area? Either I will find the length and the width and making the calculations to get the numbers, are so this is where the tips and tricks will help you to get those correct answers in order to make your exam correct. So going back into our model, so let me close this. So here we have our, you can see our model, and if I flatten it out, this is basically our bounding box length, and this is the width, this dotted here. But we will go here into the sheet and click on the properties. So here are those all the parameters mentioned here: property name, bounding box length, bounding box width, bounding box area. So if you see any sort of questions like this, what is the bounding box area of this part, what is the bounding box length of this part, so what is the bending allowance, so all those can be found from here. You just need to come into this property section and see the bounding box length, which is 245.18 millimeter. Then you need to just put this answer into the exam sheet. So same goes for the bounding box area, which is 25 7 11, and the units will be the same, which is of the part, which is millimeter in our case. So from here all those parameters can be founded whatever they want from you. Going back to our next thing is how to make the equations in our sheet metal exam. You will have to create the exam all the create the equations all the time. Like your very first question will start from the equations. Like you will be giving four equations: the length, width, height, the and then you will be creating the model based on those equations. In the next part, nothing will change, they will just change those three equations, and those you will just change those equation values, update the part, and you have to just give the answer. You don't need to create the model again. So for that, how you can create, for example, if you create a new part, You are at this stage. Your first question has mentioned like a is equal to 10, b is 20, c is 30. So what you are going to do is you can just click on s button, type in here equations, click there, add a global variable, name that variable, click on tab, put the value, and you must assign the units. So I am going to assign the units of millimeter and click again the tab. Again, click on the bottom B tab 20 mm. Again, the third one C 30 mm tab and click on OK. So you will see we have those equations here. What I will do on the top, I will create the section. This length is basically A. I will click equals A, press enter. Going back, second B, click on OK. So this is how we are going to put the equations. I am going to extrude it in direction 1, and actually we can put our C dimension here as well and click on OK. So this is how you have created this part, but this is question number 1. They will ask you to just change, keep the same question, change these parameters. Parameters are length has been changed to 15, A has been changed to 15, this has been changed to 20. You will just click on OK, it will update it. You will just evaluate or see the mass and put it on the question on the answer sheet. So this is how like you create the equations. The other way around is, if for example I want to create a sketch and I want to give it some dimension which is d basically, I will just click here. I don't need to go to the equations. I will click on equals, type the letter, press enter, create a new
I think Ali just he just left me a message that he's going to actually rearrange his mic. He'll be back in some couple of minutes. So while waiting, one thing I wanted to emphasize on is, most of the time when we are writing these exams, we need to keep in mind that we are not in a in a classroom examination where you are not allowed to actually go to the internet and do researches. It is allowed to actually be inside the exam and go to Google or go through YouTube to actually try to know important things. Let's say you are writing the exam and you want to learn how to do equations, and you don't know how to do the equations, or you don't know what is called the bounding box, or you don't. Let's take the example of the sheet metal forming tool. You don't know how to do the sheet. In fact, you don't know how to create a forming tool. Ali, you're back.
Yeah, I'm back.
Yeah, let me just finish. You don't know how to create the forming tool, like what Ali just said. You need to you can go to YouTube and actually research how to do it. If you have some times, if you have been using the equation right, if you have been doing everything right, most of the time you can finish this exam in, let's say, 60 minutes. Ali, you correct me if I'm wrong. I think if you are doing everything
Yeah,
right, you can finish this exam in actually 60 minutes. So in
even with
questions
the
where if yeah, you want to say something?
even before 60 minutes.
Even in smaller time, with a smaller time. So in question where you feel like you are uncertain, you can skip it and come back. But you can take the time to go to YouTube and actually do the researches, actually learn some couple of things. Just still during the exam is allowed. So Ali, you can go on with your presentation.
Yeah, thank you so much. So we were talking about the equations actually. So this is how like we can have directly create equations from here, and we can create equations from the equation tab as well. So moving back to the next, which is how to use bend tables. I have already shared that thing with you, how we can use the bend tables from here. Like we are going to sheet metal, editing it, and here we have the gauge table, which is actually the bend table. We have bend allowance inches, we have we can have any other browse that gauge table that we already have. And once we select that table, we can just go down and change the parameters gauge value from here, and that will like update the values accordingly. So I'm going back to the presentation. We have updating the k factor value. This is like you will be asked for a couple of times, like you have make your part ready for the k factor value of of some k factor value, and they will ask you to change that k factor value. For example, we have created our part which is zero point 0.5 k factor being used there. In the next question, they will going to ask you to change that value to 0.45, and click on just OK. And then they will ask you to again go back and find some, maybe they will ask you about, like they will give this flat pattern. They will ask you about the length, this one, like from here they will put some letter, that what is the length there. So you can just click on this thing and measure the length from here as well. You can use the measure tool to measure the length as well. So this is how actually it works, how you change the k factor value from here. Moving back, we have editing flange profiles, just like we did for the hem tool. We can change the flange, this is the flange, we are going to edit the flange. So here you can see we have added flange profile. So sometimes they will ask you to create the flange here, but they want not the whole flange, but they want some amount like this, and they want you to put the dimensions. The dimensions can be given to from them, and you can just go back. You can see we have our new flange there. And in the next component, they will also tell you to create some custom relief types. So this is the relief here. If I change it from here, you can see, drop down here we have rectangle. So here we have a rectangular relief. I can change it to tier, which is like cutting the part from here. And the third one is brown like this. And you will be asked, like a couple of times you will be asked about changing the relief type. And without using the relief ratio, they will ask you to change the length, width, and the dia. Like width can be different value, and this can also be different value, like this. Okay, so this is how you are going to change the relief types from there, and click on OK. So this is how you are going to edit the flange profiles, and you are going to work on these the relief types there. Moving towards the next, which is creating hems, we have already covered this thing. And this is like most of the times you will be asking to create the hems, to modify the shape of those hems, just like we modified the profile of the flange. So similarly we will be asking for this thing as well, hanging relief type here. So this is actually the spelling mistake. This is changing relief type, that we already have covered in the previous. And we have finding different values of the parameters, which is actually the same thing. We go into the cut list, put on the properties, we need to find the parameters from there. You will be asked, like you can model the parts with the help of tools that we have practiced, but they will ask you about what is the bounding box length. So you are going to find that parameter here, and you are going to check the value from 225 23 from this position. So moving towards the coordinate system. So in maybe one or two questions you will have to create a coordinate system. For example, if this is the face and they want you to create some coordinate system on it, what you need to do is, first of all, you have to have a point in there. So you can create some point, like for example, if I go to sketch, create, edit it, and create some, like this is the origin. I will put a point little bit away from that. So here is the point. I will close the sketch, and from the features I will go into the coordinate system. So here you have to select the position, which is this point, and from here you need to specify the axis. One, this is actually the y, and we need to specify the z, and from here we can just like change the directions whatever we want. So in order to just replicate the same thing that you will be seeing in the reference image that they will provide in the question. So this is how you are going to create the coordinate system and click on OK. So we have our coordinate system. Just make sure that your y, z and x are pointing in the right direction, similar to the one being seen in the reference geometry. So if you will see no dimension on the reference geometry, that where it is located, it is mostly located on the center of the the face. For example, this face here is the coordinate system, then this is the center point. So I will just go in there, click on the point. From here you can see center of face. I will click there, this is the center of the face. Okay, so this point can be used to create the coordinate system. So this is how we are going to cover the coordinate system. And evaluation tab, which is most commonly used in all the exams of SolidWorks. So you can just directly go in this tab into the mass properties, and from here you will see we have the mass, we have the center of mass, and for this specific question you will be asked to find the center of mass, the x, y and z coordinates. So you can get that from here, but they will ask you to find that center of mass based on the coordinate system that you have created. So this is coordinate system 1, not the default one. So I will change that, recalculate it, so this is the correct answer for that. And also you must have to like take care of the thing that if they want to see some specific, the size of specific body, the weight of specific body, you can just clear that thing and select only that specific body and recalculate it. So that's how you find the mass. So this is the basically the mass properties that will be most commonly used, and which is center of mass, surface area, and mass and volume. Most commonly will be asked is the mass, then is the center of the mass. Moving towards our template. So in order to save the time, before starting the exam, you need to just create a new part, then just go to the questions, define some random equation just like we did before, like a, which is 10. Then we need to define the other variable b, which is maybe 10. We can define the c, which is again 10. I'm just putting the random number, and d, which is again 10. So these are all the dimensions. And once we have the equations, we need to just apply the material, maybe 1060 alloy. Okay, mostly this can be used. Okay, so you can just go and save that part into any location with the name as like sheet metal template, sheet metal exam template, you can say, like this. Just save this template, and whenever you have any question, new question, you can just directly open this part and create something in there, so that you don't need to create the questions and spend time on them. So because equations are very easy when you are handy with them, but sometimes it causes issues to define and link those equations with the dimensions. Moving towards the next is our the sample exam. Now I'm not I have like the all the practical stuff has been covered. Now I'm going to just go you through all the questions, how they are going to ask the questions, how what will be the structure. So it's you who will be going to practice these questions, and before going into the exam, when you are gone through these all questions, then there is no one to stop you from becoming the sheet metal expert. So let me just uh, remove this pen, open the exam. Actually, where I can cancel it. So this is the same guide that you can get from the website. I'm going towards the question just. So, so this will be our first question. You will be having some dimensions for the values that you need to create. These are basically A, B, and C are the equations that you already have defined. But you go down, make sure to read all these the information that has been given. This information is not going to change mostly, but you need to read that for each question. For example, we have unit system, so make sure you have the same decimal points, which is not really important, but you can take care of that. But the origin is arbitrary, which is always be arbitrary in sheet metal, but in other exams you have to take care of the origin as well. Then we have the part material. You can assign that material as well. So we have the sheet metal thickness. So all these values we have been taken on, and you will be asked about mass of the part. You will model this thing with the help of the tools that we have practiced, and at the end of that you will go to the evaluate and get the mass in grams. So this is your first question. So this is first part. So now moving towards update parameters of the initial part. So our main question, we are just changing these values, four values. So we are changing the equations, and again we are giving the mass. So if you spend 5 minutes on the first question, then the second one will be in 30 seconds. So you have done two questions in 5 minutes. Going down, they will ask you to apply k factor of 0.4, which is about 30 seconds more. And they will ask you to change the parameters of the equations, maybe 30 seconds more, 1 minute. So equation changed, k factor changed, everything else is same. Just measure this x value. This is this one. You can use the measure tool from that. And so maybe in 7 minutes you have done three questions. And going down, you will again update the parameters. The k factor value changed, the equation changed. So four questions in maybe 7.5 minutes. Again, x parameter need to be uh, measured, which is the answer. Going back, we have update the parameters again, same everything, using the same parameters as given. Measure the bounding box area, which is from the, you can see the cut list, going to properties, and we can get the bounding box area. So again, in 8 minutes we have done five questions. And here we have the additional feature, which is creating the hem. And we have the dimensions for the hem. Here we can see we have to edit the hem profile, which is 2 from both sides, and we need to change this height to 10 mm. So again, this is not taking much time, but you know now where to edit the things. So this is how it will cover your next question. So these all six questions can be covered within 20 minutes, because you have like your first question is correct. But if you have your first question wrong, then rest of all the six question will be wrong, and you are out of the exam. You will not able to get the full marks, even the marks closer to passing the exam. So these are the six questions for the from the practice exam. And we have other questions in the slide. Like we have some seventh question, in which we again asking about updating the parameters. We have updated the parameters. Hem distance have been updated, which is and sorry, hem length have been remained the same. These equations again changed, but here additional thing is relief type, which is we have learned from there that how we change the width and the depth of that thing. So again, your next question is from the previous part. Updating the parameter again in the next question, just changing the k factor, nothing else. Changing the k factor, flatten the part, and now outer cutting length. This parameter can be found from the properties of the cut list. So you can just update this parameter and get this, the number from the list, which I have shown you. And then, sorry, we have updated the parameters. Again, updating the parameter, what we are updating, same everything, just we are creating the side cutout. we have a rectangular cutout, maybe we have a circular cutout in the same part. We are keeping the same part, we are just updating it with the help of maybe extrusion, maybe cut, maybe fillets. So we are just adding on feature, and our next answer is ready. So make sure you are spending your time on your first question to get that right. Then again, next question will be updating the parameters. Closed corner, here we have the closed corner gap. So this is zero point 0.2. So if I go back, maybe I can find something where it is. Let me go back to SolidWorks. Maybe in the recents I can found that, not in this one. So here we have our part, and we have these closed corners like this. We are going to like have empty space there, and we have question in which we have full overlap, closed corner gap, and open band region. These are basically already there. Open band region, you just maybe these are unchecked. You just need to check these numbers. Okay, coplanar faces. So and the values is zero point 0.2, which is here you can see zero point 0.2. You can just align them the way it is. uh, like you will be having a reference image that will be seen like this. So you need to verify that either the reference image is like this or that is like this. So you need to change that thing, and this is how you can just get the corner gap. How you will just get these empty boxes, you will select the faces, actually one and the second one, like these two faces, and then just play with these in order to achieve the desired feature. Then we have, this is the critical aspect regarding the one of the question, maybe this is the same question, something same. Okay, so we have, let me go back to meter joint, meter flange. You will be asked to create, if I go into the sketch, you will be given this sketch. You will have these dimensions. So you are going to draw this, put these dimensions, these values will be changed for your question, and then just go back and select the sketch into the sheet metal. You just click on the meter flange, you will get this tab like this one. So now you need to just put on the values here, but actually in one of the angle this value is 25. So you have to see this is 25. You will put the dimensions in here, which is 25. If I increase this value, like maybe I make it 30, you are expecting that this extrusion will increase downwards. I am putting 30, clicking enter, it's going back. So which means this D2 is not the extrusion length. It is actually the length from the face, and that is the face, this one, the base flange that we already have. So actually, let me go back. This is our base flange, and from the base flange, the whole length is till the top where we have our sketch. So our sketch is on the top, and the base flange is this one. So overall length is that we need to measure, overall length is 68.5. So you need to consider this overall length. You need to put that value in here, which is like 68.5 overall length. What you want to achieve is 25. So you need to uh, subtract that 25 and click OK. So you will just click on OK here, and you have to measure that length. The color of this dimension will be different, like just like you are seeing, this is not black, it's green, which means you have to measure this length. So if I measure this length, you will see it's 23. So you have to make these calculations. If I 43, I will change it to 41.5. It's increased, I will close it, and see the dimension is 25. So once it's 25, you are good to go. So this is how you will need to verify the dimension, what's changing in there. So this is the critical question. So now you will understand the thing. Now we have update the parameters. Again, you will asked to update that parameter. So here you can see we have 25 mm. I'm going back to the questions, changing the length to 10 to 20, 72. Okay, but we want to keep this as 25, but it's changed, it's 27. So you need to go back again. So you have to minus, actually this time we have to add 2 into it, so that we can subtract the material. So I will click on OK, click here 25, you are good to go. Now you can go to evaluate and find the mass of it. So this is how you are going to see this. And add form tools we have already done. I guess we haven't. Yeah, in the start we have worked on the form tool as well. Let me go back again. This is lower. We can just grab that, put on the face. We can flip the tool either side. We can change the angle. Actually it's 90, so we can change the angle. So this is how we'll change it. We will need to position it. We can just go to position tab, put the dimensions whatever we want, and go back to type and click OK. So we have our lure. So this is how our 13th question. And then we have other parameters like creating the pattern shown. So again, this what we I have already shown you, like we can just click on these parameters and create linear parameters. We can mirror them. Maybe if we have our plane there, go to feature, mirror it, select that feature basically, and click on OK. So we can mirror that as well. We can create linear patterns as well. So in order to achieve the desired reference that we already have. And this is creating a sheet metal part from the solid that we have already covered in detail. So that's the overall structure of the exam. And from this whole presentation, a huge shout out to this 3D Zenith, a YouTube channel that helped me to achieve my certification. And I will be more than happy to recommend this to you as well. He has already created tutorials on the exams, and you can just practice those. And after practicing those, you will be good enough to give the exams and get cleared them. And on the right, this is my channel, the Digitize Studio. You can visit that as well, where you will find some latest opportunities. So that's pretty much it for today. Thank you so much, everyone. So
For
if you
all
have
those who are interested
anything,
in the for all those who are interested in the links of the digital studio and all the different links, just make sure to leave an email and
yeah,
I'll give it to them. So for all those also who are having some questions, is the moment to ask your questions to Ali. And one thing I wanted to add is, please, one important thing that we usually recommend is save your part. Each and every time you pass a question, try to save your part. I think Ali will emphasize on that
yeah,
because I
yeah,
think it's very important because you can, if you feel you did a mistake behind, you can actually come back to that session and see where the mistake was, and you can actually
where the
rectify
mistake
the part.
was.
Yeah.
I
So
agree.
that's just it. I think you've had a lot of tips and tricks. You've had a lot in fact, you now actually know how to actually go about with the sheet metal exam. For those who need resources, Ali is ready to share with all of us. So feel free to
Yeah,
leave a message still. And
I
if there's
request
no
you all,
question,
please make sure to fill the feedback form as well. That always help me to make my future sessions amazing. And that will also help me learn from you guys. So make sure to give the honest review on my feedback form. And if you have any question, I have the section in the form for the question as well, so you can ask me that question on the form as well. I will get the answer to you in the inbox.
So
So that's
thank
it
you very
from
much,
my side.
Ali.
Yeah.
Thank you very much, Ali. I think there's no question, so we can wrap up with the event. I think we had a wonderful presentation today, and we are happy to have shared with all of you. Welcome. Thank you for all of you to. In fact, thank you for all of you to be part of us. In fact, part of our meeting. I think the event is okay, so we are going to wrap up. Have a nice day to everyone. Have a nice day to you, Ali, and wonderful presentation.
Thank you very much. Thank you very much, everyone, for joining me today. See you guys, and I'm going to like wait for all of you to see on the LinkedIn mentioning me for what you have learned from me and what helped you to achieve. So just mention me on your post. I will get back to you the to your comment section there. Thank you so much, everyone. Take care and bye bye.
Take care. Bye.